So pendulums and swings, they have a frequency that they operate at. Okay? They naturally vibrate and oscillate at a specific frequency. Everything does. We have a specific frequency. The table has a specific frequency. The lights have a specific frequency. Glass cups have a specific frequency. Okay? Every object has a natural frequency that it vibrates and oscillates at, and that's called the resonant frequency. Okay? It's the naturally occurring frequency within that object, and all objects have it, inanimate and animate objects. We can apply a force to that, okay, and we would call that a forced frequency. So what happens is, if a forced frequency matches the resonant frequency, then very little force is required, okay, to keep it moving in simple harmonic motion. If a larger magnitude of force is applied, the amplitude of the vibration, so highlight this piece. If a larger magnitude force is applied, the amplitude will increase, frequency will remain the same. These are theory pieces that you need to understand, okay? An increase in amplitude of the vibration due to force frequency is what we call mechanical resonance. So we can make that wave, right? Amplitude is from the crest, top of the crest, or the very bottom of the trough to the equilibrium line. We can make that wave go higher, but we won't change the frequency. We won't change the number of cycles per second. We just change the height of the wave. Okay? An increase in amplitude is also an increase in energy, which then can cause destruction. So, mechanical resonance explains why the voice of a singer can be used to shatter glass. The glass has a natural resonance in it. It has a natural frequency. When the singer sings and projects her voice, those sound waves come out at a specific frequency. And typically it's a high frequency. If you have a high frequency, what does that mean? What does a high frequency mean? Okay, so if that high frequency, an increased number of cycles per second, matches the natural frequency of the glass, you will cause destruction. Right here, an increase in amplitude corresponds to an increase in energy, which can cause destruction. So we go from little waves like this to larger waves like this, still the same frequency, still the same number of cycles per second, but now we have bigger waves. And so we cause destruction. Mechanical resonance also explains why when soldiers march in step, armies have been known to collapse bridges, because the bridge has a natural resonance or a resonant frequency. And when they march in step, they meet that resonance. They increase the amplitude, and then it destroys the bridge. Okay. So if the force frequency doesn't match the resonant frequency, then an increase in the amplitude cannot occur. That piece has to happen. Forced frequency has to match the resonant frequency. It's an all or none. Okay? Force frequency must match or be incredibly close to it, the resonant frequency or the natural frequency for destruction to occur. If they don't, it will not happen. You have to have that increase in amplitude. Let's look at the practice problems.